For the limiting reactant problem assignment, there are typically 4 questions that are going to be asked. They fall under 2 categories. Question type 1, which is a limiting reactant problem, and the first part is going to ask us to find the mass of a product, and the second part is going to ask us to find how much of the excess reagent remains. Now, 2 of the questions that you'll see on the assignment actually don't ask for part B. So those are actually going to be easier than what we'll go ahead and do here. And then you're going to have type 2 questions, which are going to be a word problem, which you have to convert and do a little bit more work on those. So let's start with the type 1. All of these are going to start with an unbalanced equation. So we're going to have ethanol reacting with phosphorus tribromide to create bromoethane and phosphoric acid. Phosphorus acid. So we need to balance this. And if you're looking at this, then you should remember how to balance equations very regularly. I'm going to show you the trick here to make this solve a lot faster. Start with the phosphorus. There's 1 phosphorus on the left, 1 phosphorus on the right. On the left there's 3 bromides, but on the right there's only 1. In order to get 3, we have to put a coefficient of 3 in front of the C2H5Br. Alright, so now we need to go back over here to the left. Because we have 3 of the C2H5s, we have to have 3 on the left as well. C2H5. That way, the number of carbons ends up being the same. We'll have 6 on the left and 6 on the right. When we do that now, that gives us 3 OHs. Well, if we look over here, we actually have 3 OHs over here. 3 hydrogens, 3 oxygens. So everything actually balances out now. So our balanced chemical equation is going to be 3 C2H5OH plus 1 PBr3 goes to 3 C2H5Brs plus 1 H3PO3. This is important because we're going to be converting between C2H5OH and C2H5Br, as well as PBr3 and C2H5Br. So we need to have our coefficients down before we get started. In both cases, because we are looking for the maximum mass of C2H5Br, we have to take both these starting masses of starting reagents and convert them into the C2H5Br. I'll go ahead and start with the ethanol, 24.0 grams of C2H5OH. Okay. The molar mass of ethanol is 46.07 grams C2H5OH. It's going to give us 1 mole of C2H5OH. If we look at our balanced equation, for every 3 moles of C2H5OH, there are 3 moles of C2H5Br. Again, we're going to find the mass of the C2H5Br, so we want to go to moles of C2H5Br. Then all we have to do is plug in the molar mass of C2H5Br, and that's going to be 109.97 grams C2H5Br per every 1 mole of C2H5Br. Put it into your calculator, you get 57.3 grams of C2H5Br to 3 significant figures. Alright, so now we need to do this phosphorus tribromide. 19.8 grams of PBr3. The molar mass of PBr3 is 270.6 grams PBr3 per every 1 mole of PBr3. From our equation, for every 1 mole of PBr3, we will make 3 moles of C2H5Br. And then the molar mass is going to be the same, 109.97 grams of C2H5Br Br for every 1 mole of C2H5Br. When we plug this into our calculator, we get 24.1 grams of C2H5Br. Now this is where everything gets a little confusing. I'm asking for the maximum mass of C2H5Br that can be produced when we mix these two quantities. That's this one here, the 24.1 grams of C2H5Br. Okay, that's the maximum that we can make when we mix, which means our PBr3 is the limiting reagent. Now, for 2 of the questions, that's where you get to stop. But for one of the questions, we have to go on and figure out how much excess reactant we have. In order to do that, we need to convert the mass of PBr3 to moles of PBr3, and then go to moles of C2H5OH, and then to mass of C2H5OH. Alright, so 19.8 grams of PBr3 for every mole of PBr3, we get 270.6 grams of PBr3. Okay, for every 1 mole of PBr3, we have 3 moles of C2H5OH used up. And for every 1 mole of C2H5OH, there is 46.07 grams of C2H5OH. This gives us an answer of 10.1 grams of C2H5OH actually used. So to figure out how much we have remaining, we're going to take the original mass of 24.0 grams C2H5OH original, subtract the 10.1 grams of C2H5OH used, and that's going to give us 13.9 grams of C2H5OH left over. Right? So 13.9 grams is what we have left over, and that's what we're going to put in for the answer on that question. Now let's go and work on the type 2 question. This one's going to be a little bit longer because it's a word problem, and it's going to take into effect, I want you to convert words into formulas so that you can be proficient for that for the exam. So silver 1 nitrate, we need to convert that from words into a formula. So we're going to have AgNO3. We're going to react that with sodium sulfate, that's Na2SO4. We're going to form silver sulfate, that's going to be Ag2SO4. Remember, SO4 is 2 minus charge, so we have 2 sodiums here. Silver is silver 1 still, so we'll have to have 2 silvers to counterbalance the charge on the SO4. And then we're going to have sodium nitrate as our product. Now we need to balance. Okay, again, I'm going to look at the silvers. We have 1 silver on the left, we have 2 silvers on the right, so I need to have a coefficient of 2 in front of the AgNO3, and then I have a coefficient of 1 in front of the Ag2SO4 on the right. We're going to balance the sodiums then, so we need 1 on the left because we have 2 sodiums, and we're going to have 2 sodiums on the right, so we'll have Na2 and 2 units of NO3. Right, so there's our balanced equation. Now comes the fun part. This particular question takes into account solution stoichiometry. So it's a little more complicated than what we've seen above in the type 1 questions. For solution stoichiometry, we have to take the milliliters of the reagent, convert that to liters of reagent, convert that to moles of reagent, convert that to moles of product using our balanced equation, and then convert that to mass of the product. Okay, so with this, we're going to start and do both the silver 1 nitrate to silver 1 sulfate, and then go from sodium sulfate to silver 1 sulfate. Okay, so we're going to set this up. I'll do the silver 1 nitrate first. 55.86 milliliters of AgNO3. There are 1,000 milliliters per 1 liter, and that's going to be AgNO3, and we'll multiply by 0.060 moles of AgNO3 per 1 liter AgNO3. Our molar conversion is going to be 2 moles of AgNO3 per 1 mole of Ag2SO4. And then we need to multiply by the molar mass of Ag2SO4, which is 311.9 grams Ag2SO4 per every 1 mole of Ag2SO4. This is going to give me 0.523 grams of silver 1 sulfate produced. Go ahead and do the other one real quick. Na2SO4, convert that to liters, multiply by 0.10 moles of sodium sulfate, 1 liter of sodium sulfate. For every 1 mole of Na2SO4, there are 1 mole of Ag2SO4, multiplied by the molar mass, 311.9 grams Ag2SO4 per 1 mole. Ag2SO4 gives me 1.28 grams Ag2SO4. So our limiting reactant here is going to be the silver 1 nitrate. That's our limiting reactant, and the mass, the maximum number of grams that we can produce is 0.523 grams of Ag2SO4.